You just saw 3 combat robots on a kitchen bench going ham sandwich on a piece of plastic. Yeah, about that. Hey there everybody, welcome to Krazy Grandad. My name's Bill. This is RC Hacks the second. Glossed over a few things in the first video. So I thought it might be a good idea just to touch on those things in a little bit more detail. First and foremost though, I would like to very much thank everybody who had a look at the first video. I really do appreciate it. And if you stick around, there's plenty more to come. So without further ado, let's have a look. Okie dokie. So in the first video we looked at how to recycle your old servos and bits and pieces like that to make gear motors or 360-degree servos, that kind of carry on. And that's all well and good. What I didn't do was go into basically the insides of the servos and what you need to be doing to make that happen. So that's what we're going to do today. So I've got a couple of examples here. Basically, there's 2 ways of going about it with any servo if you are changing from a normal servo to a 360-degree servo. And also that process applies if you're looking to just run like a small DC motor as well. So but we'll get into that. There's another little thing you can do as well with these circuits, and that is a bit of lighting. And we'll have a look at that. We've got the breadboard here with some LEDs and bits and pieces. So we'll have a bit of a fiddle around with that later. You saw the robots at the start of the video. I actually used to do robot combat with ARC, Adelaide Robot Combat. Give those guys a look on YouTube. They're doing some really fantastic stuff. I haven't competed for some years, but I've still got all my bits and pieces and robots obviously. But yeah, the reason there at the start of the video is because there's some of this stuff that you see here that I have implemented in the beginning when I was first building these little robots that yeah, came in really handy. So basically what we've got is this here. This is the inside. It's already sort of been modified a little bit, but this is the inside of a tiny little 9-gram servo. So this was the organ donor. This basically has been stripped of its insides, circuit board and motor. All right, so that's now basically just a husk. It's got a few gears in it and that's about it. That's the motor that would have driven the servo. Now let's get in a bit closer so we just see what we're doing. There we go. So tiny little servo motor. These aren't a lot of use. However, they do have their uses. I'll get back to that afterwards. So this here is basically, let's see if we can get in a bit closer and have a squiz. So here we have the tiny little board. Now it's a bit messy because it's been glued and all sorts of things have happened to it. But that's the little control board for the servo. Your 2 motor wires would have come off of here. I've got jumper wires on here for reasons that will become clear in a moment. And this particular one has still got the little potentiometer on it. And I don't know how well you can tell, but it's actually been snicked off with a pair of side cutters right on the shaft in the middle there. So basically what that allows it to become is basically like I suppose like a tuning pot, right? Same as you would see on a PCB. So yeah, basically these can be used for all sorts of things, because what you've now got is you've got something that has a PWM control directly from your radio that outputs a DC current one way or the other. So this can come in handy for running other motors, and as I said, it can come in handy for running things like little LED lighting systems and stuff like that. It's only low voltage. I think it's usually only about 4.5 or 5 volts coming out of these wires, so it's quite safe to use with LEDs without needing resistors and that kind of carry on. So let's have a bit of a squeeze and see what we've got. We've got a similar sort of thing here. Now this is a, you know, I can't even remember why I made this. I made this a long time ago. It's basically a linear actuator. It's got like a rack and pinion set up inside of it with a couple of reduction gears. But this motor is effectively one of these little gear motors, one of these tiny little gear motors. Now, quite coincidentally, these motors, these are what you, with the robots you would have seen at the start of the video. I use these for the wheel drives. So all the wheel drives on all of those, or most of them, have got these little motors because they're so compact, they're so easy. They've got a little D shaft on the end. You can ram a wheel straight on the end, put it on with a bit of Loctite, and you're good to go. So yeah, they're just great. They're fantastic. So that's what this is, and they're the same ratio, I believe. So basically, what we have is two systems that can be controlled directly from a receiver. So let's, you know what, let's plug some stuff in. So we'll kick off with, we'll plug this one in, and what I'm going to do is plug that into my breadboard. Just move that for a sec. Alright, so basically all that's doing, that's just running a current straight down to all those LEDs. Now two of these LEDs are one way, polarized one way, the other two polarized the other way. So basically they will take it in turns. We flick the transmitter on. There we go, we're in business. Now from memory, I think I've got that channel running off this toggle here. So let's put that one on, here we go. So we got these LEDs here are on, and then with a flick of the switch, basically, ooh, we've got a sketchy LED, no we don't. So it gives you the ability to use a channel on your transmitter for lighting if you want. And I mean, you could probably even go as far as if you could find a small low voltage relay if you wanted to control higher voltages coming directly from your power supply in your model, not a problem at all. So anything's possible. So that's a simple way of doing that. Now if we just yank that out and get that out of the road, and we've got this one here now from memory. There we go. Nope. That's going to go a bit Burko on us. Let's try that one. There we go. So yeah, this is just a linear actuator, and it's actually, even though it's got that tiny little motor and it's only taking power from the radio rail, which, let's be honest, is not much at all, that is actually able to produce quite a bit of force without robbing too much power from the radio. Because the one thing you have to remember whenever you're powering anything like this, depending on its current draw, if it starts taking heaps of power out of your RX, then that's going to affect other things that are running, other servos or whatever, speed controllers. Plus, it's going to send your transmitter absolutely nuts if you've got a RX feedback on your radio. Your radio will start having a massive sook because it thinks it's losing voltage. So yeah, and this here, I'll tell you what, I reckon there's half a cup of coffee there. Now I would have said that for a little motor like this, half a cup of coffee would be reasonably heavy. Could we agree on that? There you go, you saw it here, folks. And the power level on my transmitter for my RX didn't bat an eyelid, didn't even think about it. So this one, on the other hand, rather than having the the little potentiometer still attached. You may notice that this one, let's just zoom in again, hold on to your hats, ready? This one here has got a couple of resistors on it. Now this has pros and cons. One, it's set and forget. Once those resistors are on there, basically you've got a set value of resistance on that board and that's it, it's done. One of the main con of it is, and I don't know if you can hear it, is that's creeping, and they will creep. Depending on, there's so many factors that come into it. If that board gets a little bit warm and it changes the resistance of one of the resistors, because resistors do change with temperature, but that's creeping a bit now. I'm not touching the transmitter, but I've got a little bit of floaty dead stick on that channel. So I get it to stay still, but I reckon if I was to leave that for a couple of minutes, she'd start to, there she goes. So always bear that in mind. I would probably, if it was me, after a while, I was running my drive motors, my wheel drive motors with these when I first got into robot combat. Let's just pop back out again, ready? There we go. Yeah, I was running these on my drive motors before I sort of discovered other ways of doing it with robot combat. It's good, it's compact, it's lightweight, but you've always got that chance of that little bit of creep there. And no matter how much you try and trim it out on the transmitter, it's always going to come back and you'll wind up with a little robot just sitting there just trying to walk forward on one wheel, and it's a pain in the backside. So sometimes with these, turning this this little potentiometer that's out of your servo initially, turning that into a little trim pot, if you will, can be the way to go. All right, so let's unplug that. So I can't remember the value of these resistors here, but basically what it is there are, let's turn that tranny off, let's turn all this stuff off, turn it all off. It's getting too noisy, it was beeping and buzzing and carrying on. Right, let's squeeze back in here a bit close. Okay, so what we've actually got going on here, and I'll just find something super pointy. This setup here, you've got these resistors are set up basically like an M shape. So they're both twisted together in the middle and they're joined at the top there. So you've basically got bottom of resistor 1, bottom of resistor 2, and then the other end of both of them in the middle. So that there is where the potentiometer would have joined up. I'm sorry if it's hard to see, and I'm sorry if my hands are shaking. This is really tricky. And these resistors are basically, each resistor is half the collective resistance of the potentiometer. I'll explain all that in a minute. It can get confusing and it can get a little bit technical from time to time. Basically, it works, it's okay, but again, it's not going to work as well as like something like a trim pot or something like that. I think probably the best way to explain it is, I know, visual aid. Right, just whip this up quickly in the kitchen. Who doesn't love a good visual aid? All right, so this here is basically, if we imagine the potentiometer that's in a servo, made massive, and that would be your servo horn on your servo. All right, so let's just pretend this is all back in a servo and it's a normal working servo. So basically, I'm not going to make the assumption that everybody knows exactly how a potentiometer works, because some people don't, and that's totally fine. So we're here to learn. So basically, a potentiometer is a variable resistor. All right, you have 3 pins, 1 pin and 2 pin on the outside. They create a collective resistance right the way around. So this horseshoe part around the outside, let's say it's 10 ohms. All right. And then you have the third part in the middle with a rotary wiper. Now this is attached to the shaft, and as your servo or whatever volume dial on your stereo, whatever, moves around, it goes around and it contacts that horseshoe. So basically, if we said this was 10 ohms from there to there, and that was right in the middle, it stands to reason that this would be, yes, you're exactly right, 5 ohms. If it was around here, things get interesting. We have 10 ohms across here, but if we take the resistance between these two, that might be, say, let's say 2 ohms, and then the resistance between these two, because that's so much more, is probably going to be closer to 8 ohms, because you need to have 10 ohms in total. So basically this wiper samples that voltage, that impedance all the way around the outside, so that it can be variable. All right, so what's going on in a servo is the little board that's in the servo will say, I need this resistance to be X and I need this resistance to be Y. So it'll then tell the motor to turn until it gets to that value, which is whatever it's asked for, and then it will stop. It'll go, right, you're there, that's cool, thanks for moving. And then same thing, you move back the other way, it'll go, no, now I need this and I need this. So the motor will turn and it will bring it around till it meets it. So it's like a feedback loop. It's basically the motor and gearbox's way of telling the little board, yes, I'm there, or I'm on my way. So that's why with most remote control models, when you move your servo, if you just move ever so gently on the stick, just the tiniest little bit, you'll just get these tiny little movements. Or if you move nice and slow, you'll get nice move, slow move. Or if you just yeet it, it'll just go bang, 100 mile an hour. So hopefully that explains potentiometers for people. If not, please let me know in the comments and we might do a potentiometer video or componentry video. I don't know. Talk to me in the comments and we'll find out. Anyway, I thought that worked pretty well. Who knows? Moving right along. Now, I know what you're all thinking. You're thinking, yes, all right, we're all experts on potentiometers and this and that and the other. Enough with the flim-flam, Bill. Make with the tiny robots. All right, I said I would and I will. Let's clear up a bit. Now, first things first. What you saw getting tossed around at the start of the video was this. This is the chassis of the first combat robot I ever built. I've had it for a long time. It's printed from ABS. It's pretty tough. It's been through a bit of rough and tumble. As you can see, it's got scratches and crap all over it. It's basically been to hell and back, but that's what combat robots do. When I got out of combat robot, I reprinted a lot of my robots. I don't know, just for old time's sake, just so I've got a bit more of a new and pristine sort of version of what they were back in the day. So this one here was called Pinch Point. So let's move that. I have the current iteration of Pinch Point here. It's not completely finished. Basically, it was a good little robot, fairly simple. 2-wheel drive. Most of the robots you would see in this class, this is ant weight class, 150 grams maximum weight, really small. But yeah, good fun, awesome fun to start out combat with. And yeah, this one actually did quite well, not too bad. Wasn't that fast, but oh look, it was, yeah, awesome fun. Yeah, quite a good little sort of, it's not really a weapon system, this is more of just a grappling system for grabbing other bots. These nice little barbs on here, they'll sort of, even without power, they'll hang on, they grab hold of things, hence the name. Most of the robots we used to build were, there's a word for it, I can't remember what it is, but basically means that they will work both right way up and upside down. So this does not necessarily need to be what they call self-riding. You'll hear in, if you're into your robot combat on TV or whatever with the big bots, you'll hear people talking about self-riding bots, and they are bots that can't get stuck so that they can't move. So this one was round on the back, so it would fall either way, and it would also work upside down just as well. So the jaws could open either way, no problems. And even if it landed on its side, the sides were rounded, so that basically this will actually sit like that very precariously, but with a quick flick of the weapon, it'll just tip over that way and you're off. So this one here, let's just zoom in real quick. This one, as I said, it's not finished. There's still a few guts to go in, but I can give you a bit of a rundown. Ready? There we go. Try not to get seasick with the zoom. So yeah, in here we've got our 2 drive motors. Now, so when I first started running this, I was actually running one of these boards with a couple of the resistors on. Like we saw here, the little, we'll call them the creepy boards because they tend to creep, on each one of those motors, so that basically I could just run both of them straight off of the radio. So there was no need for any speed controllers or anything like that. So basically, as far as the radio was concerned, I had these two and the servo for the jaw. So that servo just runs straight through there, operates the jaw directly. It's not heaps powerful, but it used to do the job. So it was good. It kept things really simple and really compact, and more importantly, it kept things lightweight, because trying to keep these things inside 150 grams is really tricky. So battery would live in the middle. You would have your battery, lithium polymer battery. Obviously you don't want that getting hit during combat. You see there's an air gap behind there. We just put a bit of something behind there, usually like a very thin sheet of titanium or something like that. And then apart from that, you wanted all of your guts as protected as possible, so everything was nestled in the middle where it couldn't be harmed. My biggest downfall with this was, and I'll just show you, this fits the old one, but for some reason when I reprinted it, it must be a variation. This is the top cover, and I had this nice beautiful clear cover that was awesome. Unfortunately for me, which I didn't think about, it displayed to my opponents where everything was inside the robot, so they knew exactly where to aim to destroy stuff. But that's okay. So basically I moved on and I did an evolution of this one, which is the green one that you saw in the video. So let's hop out from that and we will get pinch point out of the road. And then version 2, very, very similar. This one is called Fallout. I don't know why I called it Fallout. It's just the, I don't know, the radioactive green, I suppose, was a bit of inspiration. We upgraded a few things. And basically, when I say we, there's me and a friend of mine, team of 2. We moved from aluminium weapon components to, this is grade 4 titanium. So these jaws on the front are quite a bit thicker, and then this one on the top is quite thin, but it's also quite springy. It'll bend quite a bit, which used to come in really handy. But this again would drop onto things and grab hold of things, and just it wouldn't let go. You didn't need to apply a lot of pressure with that servo for it to hang on to stuff. And again, this one could self-right quite happily. In fact, this one actually has the ability to flick the arm right through the middle of itself and flick itself over. So if you were upside down, you could just flick your jaw right round and tip yourself over the right way. And this thing is laid out pretty much exactly the same inside, but with one major difference. So by the time I had made this one, I had moved away from the little servo boards, and I was introduced to these little things. Now these are a dual channel speed controller. As you can see, incredibly compact. They're smaller than a postage stamp. Let's just zoom in again real quick. So these here allow you to take power straight from your battery or whatever. You have two PWM inputs that go in on one corner, main power from your battery or your power source, and then these four little pads on the back. Two of them go out to each motor. So it's basically an ESC, but it's split in two for two motors. So it gives you that, whatever you want to call it, caterpillar steer, sort of skid steer drive. This was an absolute godsend because these things are, one, there's no creep. Obviously, they work just like a speed controller should. The other thing was these things have got they've got mixing built into them. So you don't have to go into your transmitter and muck around with mixing and that on your sticks to be able to drive it. So I could basically wire one of these up, put it straight in, bind the radio, and then depending on what channels I plugged into those two little PWM inputs I should say, usually gave me the ability then to just basically drive the entire robot on one stick. So forward was forward, backwards was backwards, left was left, right was right. Simple as that, you know, very easy to drive. And then that frees up your other stick for, you know, this kind of flim flam or whatever else you got going on the robot. So yeah, so again, very compact. I think this one weighs about 148 grams. And as you can see, this one I haven't actually reprinted yet, but this one's had a fair bit of rough and tumble as well. As you can see, the plastic's worn a lot of it. The titanium hasn't even been scratched, and I mean that's been hit with other titanium, so that's not doing bad. The top's aluminium, couple of spinner grazers. There's a nice big hole in the back of it, but again we have padding in the back. That yellow bit there is a piece of plastic in the back that just stops any of the vital organs from getting smacked. So yeah, this one's it's cool. The only problem I used to have with this is the motors I had in this are insanely fast. So this thing is actually incredibly difficult to drive. So yeah, basically, so again, that was with the little servo boards. That was sort of the evolution from them. But that said, I did build a couple of bots after that where I did actually keep using them. And let me show you. I'll show you the next one. So that's Fallout. The next one I built after that. Now this one was a particularly good bot. This one is called Rhino. Basically, mainly covered in titanium. This is a flipper, stored energy flipper bot. So basically, spends most of the time driving around like that. Comes up to an opponent, bang, goes off like a mousetrap. She's showing her parts at the moment because normally these sides and these front panels would be covered in titanium also, very thin stuff to keep the weight down. And we don't have a battery in there at the moment. The battery would normally live in that hollow there. But yeah, concealed on switch. We generally used to turn them on with a screwdriver, just sneak in through a hole to switch them on. This was excellent. This was absolutely unreal. It was a little bit more complicated in terms of the wiring within, as you can probably see. Yeah, this had all sorts going on inside of it. That basically, this was my trophy winner. And I know it sounds stupid holding something in the palm of my hand saying trophy winner, but it did a good job. This was when I started moulding my own tyres out of silicon as well. Got a couple of splits there, couple of love taps from bits and pieces here and there. But yeah, so you know, things evolve as you're doing these sorts of things. Started making our own tyres, getting better grip, and that's what this thing was about. As you can see, this thing looks like it's designed to push, and that's exactly what it was designed to throw stuff in the air and just bulldoze basically, and that's exactly what it did, and it did it well. So let's maybe have a bit of a closer look inside this one. Right, yeah, we've got the wheels off. Let's have a bit of a look inside Rhino. I have a feeling this is going to be tricky because things are small and lighting's not as good as it could be, but we'll give it a shot. Okay, we'll start off at the bottom. Okay, so in the bot, we've basically got two sides to the robot. All right, the left-hand side has got all of the wizardry in it, right, that makes it work. The other side basically just houses the battery and the power switch. So that's sort of a weight thing and just basically space, because as you can probably imagine, there's not a lot of room in this. So we'll kick off at the bottom. Down the very bottom here in the floor pan, we have the radio board, or basically the receiver. Just a normal everyday FlySky RX, just like one of these here. Only difference being it's had the outer shell taken off and a few unneeded pins removed, more just for space saving and weight saving. All right, it sounds ridiculous, but you know, those little pin outs, if you can get a few of them out, if they save you a couple of grams here and there, sometimes with these bots it all counts. This one here is right on the line of 150 grams. It is as heavy as it can be. That's why it's got all these speed holes everywhere, because otherwise you'd go to weigh it in. If it's 151, is no es bueno. So, all right, radio board. Next to that, we've got this here is just a voltage regulator. All right, this thing runs a 2S LiPo. All right, so, and there are certain things on here that can run straight off a 2S, no dramas, and then there are other things like the radio that just cannot. So that's a 5 volt voltage reg, just stops things from being fried. Straight up from that, we've got, if you can see it, right here, we have, this is one of those dual channel ESCs, okay? So you can see sort of how tight a spot you can get them into. And if we have a good look, those 4 wires there, that little ribbon, they're actually the output wires for the motors. All right, so basically that will follow through to the back of the bot, splits into 2, and then 2 wires to each motor. All right, and then if we go up from there, we have a gear motor. Now that gear motor is basically runs the little reduction gear that resets this business. All right, so it needs heaps of torque. These springs, they don't seem like much, me sitting here squashing them, but you got to remember there's enough power in this little dealio here to basically toss another robot clean across an arena, and it used to be able to do it, not a problem. So this motor here is exactly the same. If you watched the last video, that little truck that I had with the winch on the front, all right, and also the wind-up key, both had the same motor, 100-to-1 ratio, even though they're small, very, very, very torquey, all right. And if you have been playing along at home, if we have a look here, what do we see? This bloody little thing. It's a servo board with a couple of resistors on it. So this is the 3rd bot I built, all right, and I'm still using these things, and you're asking yourself, why Bill, why are you still doing it? And the reason is as follows. All this had to do, when I was running the bot, it just had to make that motor turn for just a fraction of a second, just a few degrees. That's all I needed out of it. Once that happened, basically the weapon would go off. As soon as that happened, there's a little switch in the back here, micro switch. Right, we can see it there. As soon as that switch opened, it basically closed a circuit that would then supply full DC power directly from the battery straight to that motor. You're probably wondering, well, okay, Bill, that's fantastic. How was that happening and not just completely nuking this little board from space. Well, the thing is tucked in there, and you probably can't see it. Maybe right there is a dirty great big diode. So that diode used to stop any feedback current. So a little bit complicated, but it did the job. So basically, if we imagine more or less quick flick on the stick, just a quick boop on the stick, and that was enough to set it off, and then I didn't have to do anything. It would go kabang, and then it would reset itself automatically, and then it'd be waiting for me next time to on the stick again and kaboom again. As far as the mechanical sides of things go, this is reasonably sort of hard to explain without, if only I could, we need another visual aid. Hang on a minute. Okay. Luckily, this is the actual Rhino that saw combat. Printed out of ABS, as you can see, completely ruined. Big chunks out of it. Made an absolute mess of it. But when Rhino died, luckily, the organ donor box was ticked, so I was able to donate its body to science. So let's have a good old look inside. So basically what I've done is I've just macroed this. I've just cut it clean in half. Rather than a spring, I've just got a little rubber band here, all right? And you can see this sort of weird looking gear system, all right? Now these are pedal gears. They're not sort of your normal involute gears. I chose these gears because they're basically tougher. They can put up with more abuse being knocked around, and they're not as likely to strip as normal gear teeth would. So basically the way this used to work, if you can imagine this little gear, you'll notice there's two teeth missing off of that tooth, off of that gear. So basically that would allow it to go kabang-a-bang, all right? Once that happened, this switch basically supplies power to this motor, and then this could then turn around, catch those teeth again, and come around to a point where it was just hanging onto the top tooth, literally set like a mousetrap, ready to go, all right? And I had it timed just right, so it would just sit there. So the tiniest little tickle on the transmitter stick, and whack, away she goes again. I've actually, I have to be honest, I haven't just cut this in half. I got some footage beforehand of how it actually works, so I'll show you that right about now. So basically what you can see is it going through a cycle, and it's very, very simple how it works, and it was very simple and very reliable. I got that footage before rather than doing it here and now. I could have plugged this in and done it, but I'll be honest with you, that little bit of footage, it took me about 900 goes, so thanks for coming. So basically, yeah, so a direct circuit to reset it, and then it will come around, switch that little switch and turn itself off, and then it would be just down to the little servo board, right, PWM controlled servo board, just to take the cheese, and bang, off she goes again. So hopefully that explains it. I know there's a couple of the boys from ARC, if they're watching this video, they're going to be lapping this up, because I used to get asked so many questions, how does it work, and I never used to tell anyone. But you only live once. So there we go. Well everybody, I'd like to thank you all for hanging around. I know it's been a bit of a long video today, bit of stuff to get through, but yeah, look, I hope you all enjoyed it. I hope everyone's sort of maybe learnt something, or it's given you some ideas for something. Look, I've had fun doing this, and I look forward to seeing you in the next one. If anyone's got any questions or anything like that, please let me know down in the comments. Any feedback would be great. And yeah, in the meantime, everybody, have a safe and happy Christmas. Until next time, take it easy.